If you go back just 10 generations, about 300 years, you mathematically have over 1,000 ancestors. Go back 30 generations, or 1,000 years, and that number balloons to over 1 billion. Of course, that's more than the total number of people who have ever lived on Earth, which means many of those ancestors repeat in your family tree. In other words, your lineage overlaps with nearly everyone else's. Whether your family speaks Mandarin, Swahili, or Spanish today, the math doesn't lie. We're all leaves on the same ancient branches. Every culture, language, and tradition traces back to common origins. We're strangers only on the surface. In fact, every person alive today, no matter where they're from, shares a connection to a small group of humans, thought to be the same people who lived in Africa hundreds of thousands of years ago. That's the core idea behind the out of Africa theory, one of science's most famous stories about how we became ourselves. But what if there's more to the story than we thought? The out of Africa model says Homo sapiens evolved in Africa around 300,000 years ago. Then, roughly 70,000 years ago, a group of these early humans began migrating to other continents, eventually replacing older hominins like Neanderthals. This idea isn't just a guess. For decades, discoveries have backed this story, like the 195,000-year-old Homo skeletons in Ethiopia and the groundbreaking genetics research on mitochondrial Eve. Even climate data supports it, which is why many researchers find the evidence undeniable. But here's where things get even more interesting. In recent years, fossils like the 180,000-year-old Homo sapiens jaw found in Mount Carmel and ancient skulls in China have quietly asked, did we really leave Africa just once? Or was there more back and forth migration than we thought? If there's one thing human history teaches us, it's that we're always uncovering surprises. Africa is like a treasure chest of human origins, filled with a vast amount of fossils. Take, for example, the Jebel Irhoud site in Morocco, where paleontologists found skulls dating back 300,000 years. These aren't just old bones. They show a mix of ancient and modern features, like a flatter face and a rounded brain case. This could mark the earliest chapter of Homo sapiens evolution. Fast forward to Ethiopia, where 195,000-year-old skeletons look almost identical to people today. If humanity has a birthplace, these fossils suggest it's Africa. But this story isn't just written in bones. Genetics has also become a time machine for tracing our roots. Let's look at mitochondrial Eve, the woman whose DNA is found in every living human's mitochondria, the powerhouse of your cells. By studying mutations over time, scientists traced her back to Africa roughly 150,000 to 200,000 years ago. Similarly, Y-chromosomal Adam, the paternal counterpart, points to Africa around the same time. It's like finding your ancestors' fingerprints in your own body. These genetic clues reveal something striking. All non-Africans share a subset of the diversity found in African DNA. Think of it like a family tree. If you're from Europe, Asia, or the Americas, your genes likely branch off from a group that left Africa around 70,000 years ago. Even the Neanderthal DNA found in some of us supports this. When those early migrants met Neanderthals in Eurasia, they mingled, leaving a genetic souvenir. Since Neanderthal DNA isn't found in older African populations, it backs the idea that interbreeding happened after the big migration. Now some ask, why even leave Africa? Climate shifts might hold the answer, where around 70,000 years ago, the planet was a roller coaster of ice ages and droughts. Africa's ecosystem swung between lush and bone dry. Some researchers believe a shrinking green Sahara pushed our ancestors toward coasts and rivers, and eventually out of the continent. There were also genetic bottlenecks, or drops in population during harsh times, explaining why non-Africans have less diverse DNA today. It's as if only a small group survived to spread their genes worldwide. But maybe the most relatable evidence is what our ancestors left behind. In South Africa's Blombos Cave, archaeologists found 75,000-year-old tools etched with geometric patterns. These weren't just for survival, they're early art, proof of complex thought. Similar artifacts appear in later Eurasian sites, like a cultural thread connecting Africa to the world. Even innovations like heat-treating stone for sharper tools started in Africa, then appeared globally after migration. Coincidence? Probably not. Haven't older tools been found outside Africa? Sure, Homo erectus, our ancient cousins, left Africa millions of years ago. But here's what people often misunderstand. The out of Africa theory isn't about all hominins, only specifically Homo sapiens. Modern tools, art, and genes all point to a newer wave that brought our species to dominance. Of course, science isn't static. New fossils and DNA studies keep reshaping the story. But for now, the out of Africa theory ties together genetics, fossils, and archaeology into a coherent, even if incomplete, narrative. It's like finishing a 1,000-piece puzzle and realizing half the pieces are still missing. But the picture we do see, Africa at its heart. Recently, a growing number of discoveries have emerged, suggesting our story might need a rewrite, or at least a few important footnotes. We found fossils that don't quite fit the old rules. Take Mislia Cave, where archaeologists uncovered a Homo sapiens jaw dating back 180,000 years, about 100,000 years earlier than the official migration wave. If modern humans were already in the Middle East that early, did they leave Africa in multiple waves, or maybe even return? Back in 1978, the Dali Man, a 260,000-year-old skull from China, baffled scientists. It had the pronounced brow ridge of an archaic human, but a skull rounded like a modern one. Perhaps different human groups evolved in parallel, borrowing genes and traits much like neighbors sharing recipes. Even Africa holds surprises. Homo naledi, a small-brained hominin found in South Africa's Rising Star Cave, lived just 300,000 years ago, at the same time as early Homo sapiens. If our advanced species coexisted with others, maybe we weren't the only show in town. Maybe collaboration, not replacement, explains our rise. For years, studies relied mostly on DNA from non-Africans because ancient African DNA is tough to recover due to heat and humidity destroying genetic material. This gap distorts the picture. In 2020, research on West Africa's Mende people revealed DNA from a ghost population, an unknown hominin that mixed with humans as recently as 10,000 years ago. The Homo floresiensis is a tiny human species that survived in Indonesia until about 50,000 years ago. Their existence shows that other hominins thrived long after Homo sapiens began migrating. If replacement was inevitable, why did these mini-humans outlast Neanderthals? Maybe the takeover wasn't as swift or as total as once thought. This brings us to the multi-regional hypothesis, the underdog cousin of the out of Africa theory. Instead of a single African exodus, it argues that ancient humans, like Homo erectus, evolved across Africa, Europe, and Asia, swapping genes over millennia. While most scientists reject the strictest version, some now blend both theories. But the juiciest idea is hybridization. We used to think Homo sapiens replaced Neanderthals entirely, yet recent findings from Shanidar Cave in Iraq show Neanderthals and humans overlapping for thousands of years, burying their dead with flowers and tools. Geneticists now estimate that up to 6% of some modern human DNA comes from archaic groups, far more than the old 2% Neanderthal figure. This raises a bigger question. If we coexisted, why did Homo sapiens survive? The old answer, superior brains or tools, is losing ground. Neanderthals had art, medicine, and complex hunting strategies. Maybe it was just luck, a volcanic eruption, climate shifts, or sheer population numbers. Or perhaps Homo sapiens were simply better at networking, turning fragmented tribes into global communities. We should also remember that science doesn't happen in a vacuum. Early 20th century fossil hunters often dismissed Asian or African contributions, framing modernity as a European achievement. Even today, underfunded research in places like Southeast Asia leaves gaps in the data. Some critics argue that the out of Africa theory risks oversimplifying a saga that belongs to all ancient humans, not just those who left Africa. Does this mean the out of Africa theory is wrong? Not exactly. It's evolving into a collaborative story, not a solo mission. Imagine humanity's origins as a potluck dinner. Africa brought the main dish, but other continents added their own flavors. And the result is a species remixed by time, climate, and countless chance encounters. So, why does this debate even matter? It's easy to think of human origins as just a dusty academic topic, something only for textbooks and museums. But the way we tell our story shapes who we think we are. Origin myths have always defined cultures. Whether it's the Cherokee's great buzzard shaping mountains or the scientific narrative of a single species rising from a continent, each story carries real weight. The out of Africa theory, for all its evidence, isn't just science, it's part of humanity's ongoing quest to understand itself. Imagine science as a spotlight. For decades, that spotlight focused on Africa, Europe, and parts of Asia, leaving entire regions in shadow. Southeast Asia, Oceania, and the Americas are rich with unsung stories. For example, cave art in Sulawesi, Indonesia, dates back 45,000 years, older than Europe's famous Lascaux paintings. And in Monteverde, Chile, an astonishing 15,000-year-old settlement was discovered, rewriting the timeline of humans in the Americas. These finds remind us that every corner of the globe has a voice in our collective history. This isn't about picking sides, it's about celebration. Whether our ancestors walked out of Africa once, twice, or a dozen times, their legacy is your legacy. Your DNA is a living archive of Ice Age survivors, island hoppers, and storytellers who crossed continents. And while we might never have all the answers, that's the thrill of science. The closer we look, the more wonders we find.